Good morning, friends. Today we are going to discuss the new point on the same topic, states of matter. Today we are going to discuss the intermolecular forces and thermal energy. So before we will start intermolecular forces and thermal energy, what is the relation or connection between them? We know already what is meant by intermolecular forces. Yes, intermolecular forces. Intermolecular forces are the type of attractive and repulsive forces. Okay, type of attractive and repulsive forces present between two neighboring molecules. दोन जवळच्या मॉलिक्युल्समध्ये जे अट्रॅक्टिव्ह टाईप्स ऑफ फोर्स किंवा रिपल्सिव्ह टाईप्स ऑफ फोर्स असणार आहे त्या फोर्सला काय म्हणणार इंटरमॉलिक्युलर फोर्सेस. जर डिस्टन्स हे आपण आधीच लास्ट लेक्चर वी आर ऑलरेडी डिस्कस्ड वन जस्ट इंट्रोडक्टरी लेवल आय विल वॉन्ट रिपीट वन्स अगेन. दोन मॉलिक्युल्समध्ये डिस्टन्स जर कमी असेल तर इंटरमॉलिक्युलर फोर्स स्ट्रॉंग असणार आणि दोन मॉलिक्युल्समध्ये डिस्टन्स जर वाढत गेलं तर इंटरमॉलिक्युलर फोर्स ऑफ इंट्रॅक्शन वीक होत जाणार. ओके, दॅट इज वी स्टडीड ऑलरेडी इन केस ऑफ सपोज इफ यू कन्सिडर the solid state. If you consider solid state, in solid state, yes, arrangement of particles, that is constituent particles, atoms, ions or molecules. जर आपण बघायचं झालं तर सॉलिडमध्ये अरेंजमेंट अशी असणार आहे. सॉलिड केसमध्ये अरेंजमेंट ऑफ पार्टिकल इज लाईक दिस. अरेंजमेंट ऑफ पार्टिकल्स इन केस ऑफ सॉलिड स्टेट इज लाईक दिस. ऑल द atoms are very close to each other. There is a much less or almost negligible intermolecular space is there, isn't it? And the distance between two molecules is very, what we call as very less, that is the strong intermolecular forces, isn't it? In case of gaseous state, in case of liquid state, they consider kela. The liquid state with the arrangement of particles are like this. In case of liquid state, the arrangement of constituent particles is like this. There is a somewhat space is there between two constituent particles in liquid state one. In liquid state one, and if you consider the gaseous state, if you consider gaseous state one, in gaseous state the constituent particles are much more away from each other. There is no any sort of intermolecular force of interaction. Okay, means in short, solid to liquid, liquid to gas, if you observe carefully, then we find the relation between intermolecular forces and thermal energy. Just carefully look here. Solid state. In solid state, the distance between two neighboring atoms is very less due to strong intermolecular force of interaction, isn't it? As you go from solid to liquid, liquid to gas, the distance between the molecules goes on and increases. And as the distance between molecules goes on and increases, in the sense that is the intermolecular space increases. Okay, see, in between these two molecules, the space is much more. In between these two molecules, space is less as compared with the gas. And in between these two molecules, the space is much less as compared with the liquid and gaseous state. As compared with liquid and gaseous state. Now here thermal energy in the sense, just consider thermal energy in the sense temperature. Consider thermal energy as a temperature or heat. Thermal energy means heat किंवा temperature जर consider केला, heat किंवा temperature consider केलं, solid state आहे. Solid state चं temperature आपण increase केलं. Okay, if you increase the temperature of solid state or if you heat the solid substance one, then what happens? The whatever strong intermolecular force of interaction present between two neighboring molecules, ह्या दोन neighboring molecules मध्ये solid state मध्ये जे strong intermolecular force of interaction आहे due to increase of temperature or heat, that is indirectly we say that thermal energy, this force becomes weak and weak, and as the intermolecular force becomes weak and weak one, these two molecules goes away from each other one and attains the state that is the liquid state. That is the liquid state where the intermolecular force between two molecules is weaker as compared with solid state. Is weaker as compared with solid state. That's why solid to liquid is there. Solid to liquid is there. But thermal energy, as far as concerned thermal energy चा विचार केला तर thermal energy solid state मध्ये कमी, but from solid to liquid state thermal energy increases one. And due to increase of thermal energy, molecules goes away from each other. Molecules goes away from each other. That's why molecules goes away from each other. Liquid state. Again, if you increase the temperature of liquid state, liquid ला आपण heat केलं किंवा temperature increase केलं. As you increase the temperature of liquid state, whatever weak intermolecular force of interaction which is present in between the two molecules, neighboring molecules in liquid state, that force of interaction totally break down. And due to totally breakdown of the what we call the force of interaction one, these two molecules goes away from each other. There is no what we call as a relation between these two molecules. There is no any sort of interaction between the two neighboring molecules in case of gaseous state. in case of gaseous state. There is there one word is there, that is the gases are random in motion. Random in the sense they can move anywhere, everywhere in the space available. But जिथे जिथे त्यांना जागा असेल तिथे ते मूव होऊ शकतात. That is one of the most important characteristic property of gaseous state. Gaseous state one. So again, if you consider solid to liquid, liquid to gas, just if I would like to one sequence, then intermolecular force of interaction. Okay, intermolecular force of interaction or forces, if you consider, then this intermolecular force of interaction increases or decreases from solid to liquid, liquid to gas. Intermolecular force of interaction decreases one. Okay, intermolecular force of interaction actually in this direction, solid to liquid, liquid to gas, intermolecular force of interaction decreases. Intermolecular force of interaction decreases one, solid to liquid, liquid to gas one. And at the same time, if you consider thermal energy, from solid to liquid, liquid to gas, if you consider thermal energy goes on increases. Thermal energy goes on increases. जर थर्मल एनर्जी वाढत गेल्यामुळे काय झालं त्यांच्यामध्ये सेपरेशन झालं. दॅट्स वाय सॉलिड, लिक्विड आणि गॅसेस स्टेट्स आपल्याला अवेलेबल असतात ड्यू टू डिफरन्स इन द थर्मल एनर्जी अँड इंटरमॉलिक्युलर फोर्स ऑफ इंटरॅक्शन. सो जस्ट इफ यू वॉन्ट टू relate the relation between thermal energy and intermolecular force of interaction and intermolecular force of interaction. Yes, what is the relation? Yes, between in thermal energy, intermolecular force of interaction. Just if you increase the thermal energy, intermolecular force of interaction becomes weak. Okay, that's why relation between these two is the inverse proportional. Relation between them is the inversely related. Means the intermolecular force of interaction and thermal energy, they are inversely related with each other. If you increase the thermal energy जर increase झालं तर intermolecular force of interaction goes on decreases. And if you decrease the thermal energy, intermolecular force of interaction goes on and decreases. Intermolecular force of interaction goes on and decreases. That's why in solid, intermolecular force of interaction is strong. In case of liquid, intermolecular force of interaction is weak. And in case of gaseous, the intermolecular force of interaction is very weakest. Isn't it? Then after that, next point, that is the some characteristic properties of gaseous state, where we will discuss. Some characteristic properties of gaseous state. Isn't it? Characteristic properties of gaseous state or gas. Of gaseous. Now, characteristic properties of gaseous means how gaseous state is different from that of the liquid and solid state. Gaseous state हा liquid and solid state पेक्षा वेगळा कसा आहे, कोणकोणत्या प्रॉपर्टीज मध्ये फरक आहे. सी फर्स्ट प्रॉपर्टी, that is the if you consider gaseous one, the gases do not have definite shape and what we call as definite shape and volume. गॅसेसला कुठल्याही प्रकारचं डेफिनेट शेप किंवा व्हॉल्यूम नाही आहे. ओके, शेप नाही आहे आणि व्हॉल्यूम देखील नाही आहे. जिथं ज्या कंटेनरमध्ये तुम्ही गॅस फिल केला त्या कंटेनरचा जो शेप आहे तो ऑक्युपाय करणार. आणि इव्हन गॅसेस डू नॉट हॅव डेफिनाइट व्हॉल्यूम. ओके, डू नॉट हॅव डेफिनाइट शेप अँड व्हॉल्यूम. इज इट गॅसेस. द नेक्स्ट प्रॉपर्टी, दॅट इज द one of the most important, that is the gaseous, the intermolecular, that we already studied. Intermolecular force of interaction or attraction is very weak. In case of gases. That's why all molecules are separated from each other. Separated from each other. सगळे molecules एकमेकांपासून separated. That is like word as discrete molecules. That is the discrete molecules. त्याला आपण शब्द काय येतो, discrete molecules. All molecules are separated from each other. त्याला म्हणतो आपण discrete molecules. Discrete molecules. Okay. Intermolecular force of interaction is very weak. All molecules are separated from each other. That is their discrete. That is their free to move. One more point. That is that motion is called. They are random in motion. Gaseous molecules are random in motion. Motion of gas molecule is random motion. In the sense they can move anywhere. Then third point, that is the one of the most important property that possessed by gaseous, that they undergoes the process of diffusion. They undergoes the process of diffusion. Yes, diffusion. What is diffusion? We'll going to discuss in next. Okay, after some time. Undergoes process of diffusion. Then fourth one, that is the density. Density of gas is very low. Density of gas is very low as compared with the solid and liquid state. As compared with solid and liquid state. Solid and liquid पेक्षा gases ची density जी असणार आहे, density असणार very very low असणार आहे. ठीक आहे. One more property that is the gases undergoes or gases are highly compressible. Gases are highly compressible. Gases are highly compressible. Okay. Gases are highly compressible as compared to solid and liquid state. As compared to solid and liquid state. So these are the some important characteristic properties that differs the gaseous state from the solid and liquid state. That differs the gaseous state from solid and its liquid state. Now, one more point that I will go to discuss. Actually, these characteristic properties, out of these characteristic properties, some properties we are going to discuss in detail. Okay, some properties we are going to discuss in detail form. So there is under the heading measurable properties of gases. Under the heading measurable properties of gases. You see. Measurable properties of gaseous state or just gases. Measurable properties of gas, simply. Measurable properties of gas. Now, what is measurable properties of gas? See, there are different measurable properties of gas. All these are, suppose there is the mass, volume, density, temperature, then next pressure. Okay, mass, volume, density, temperature, pressure. Then one more point, diffusion, etc. Okay. These are the measurable properties of gases. Now one by one we are going to discuss mass. If you consider mass, it is the mass of gas. It is the mass m of gas. Mass m of gas is nothing but the amount of matter it contains. Okay, amount of matter it contains. त्या gases मध्ये किती amount आहे त्याचं explanation सांगणं म्हणजे त्याचं mass सांगणं. Okay, amount of matter it contains. Okay, so generally mass of gas. Okay, mass of gas is related with the number of moles and molar mass of gas. What is number of moles of gas? What is molar mass of gas? Okay, all these things we will discuss in the next topic, that is some basic concept. Okay, some basic concept of chemistry. Now see, what is the number of moles of gas? So number of moles of gas n is equal to small n is equal to, that is a small m by capital M. Okay, small m by capital M. What is this? Small n is the number of moles of gas. Small n is the number of moles of gas. N, small n is equal to small n mass of gas. It is mass of gas divided by capital M is the molar mass of gas. Capital M is the molar mass of gas. Capital M is the molar mass of gas. So this is the important here. Mass of gas is generally expressed in gram or kilogram. Generally expressed in gram or kilogram. Okay, mass of gas is generally expressed in gram or kilogram. One more point, that is the all these next what we call as formulas. That is the number of moles related with Avogadro's number of moles related with the volume of the gas at STP. All these were discussed in the some basic concept of chemistry in detail. Okay, just in this topic, just remember that mass of any gas is nothing but simply matter, amount of matter that it contains. And this is related with simple formula, n is equal to m by capital M. So this small m, mass of gas, means weight, 1 kilogram, 2 kilogram of the gas in this way. And small capital M is the molar mass of that particular gas. What is molar mass? Again, that will be also comes into some basic concept of chemistry. Simply, it is the mass of gas. Then next, volume of gas. In mass of gas, one more conversion is there. That is the 1 gram is equal to 10 raised to minus 3 kilogram. 1 gram is equal to 10 raised to minus 3 kilogram, or 1 kilogram is equal to 10 raised to 3 gram. The next one, it is this mass is completed. Volume. As far as volume is concerned, volume V of gas, that is nothing but that is the space occupied by the gas. Space occupied by gas. Space occupied by gas म्हणजेच त्या गॅसचं व्हॉल्यूम असणार आहे. Okay, means actually it takes the shape and the volume of the container, shape and volume of that particular container. Okay, if you fill the gas in suppose cylindrical असा सिलेंडर आहे vertical, त्या सिलेंडरमध्ये गॅस फिल केला तर ह्याचं व्हॉल्यूम जे असणार आहे तेच ते गॅसचं व्हॉल्यूम असणार आहे. सपोज राऊंड फॉर्ममध्ये एखादा असेल बलून, ह्याचं व्हॉल्यूम जे असणार आहे तेच त्यामध्ये भरलेल्या गॅसचं व्हॉल्यूम असणार आहे. मीन्स इन शॉर्ट, आणि त्याचा शेप पण असणार आहे. इजंट इट? दॅट्स वाय gas occupy the shape and volume of that particular container. Generally, volume of gas is expressed in liters, or it is expressed in decimeter cube, or also expressed in case of this is centimeter cube, or milliliter, or meter cube, etc. These are some units from by means of which one can express the volume of the gas. So 1 liter is equal to 1 dm cube. 1 liter is equal to 1 dm cube is equal to 10 raised to 3 ml is equal to 10 raised to 3 centimeter cube is equal to 10 raised to 3 centimeter cube. Remember, 1 liter is equal to 1 dm cube, 10 raised to 3 ml is equal to 10 raised to 3 centimeter cube, isn't it? This is the simple conversion between the liter and dm cube. Mostly we are going to what we call as use the unit to measure the volume of gas is the decimeter cube. Is used to determine the decimeter cube, dm cube. Remember that, isn't it? Okay. Then after that, next measurable property, that is the density. Yes, density of gas is nothing but density of gas we might be already studied in the physics formula. Density of gas is nothing but the mass per unit volume. Mass of gas, simply mass of gas divided by volume of gas. Okay, so it is density D of gas. Density D of gas is the mass of gas divided by volume of gas. If suppose mass of gas is expressed in gram and if volume is expressed in suppose cm cube or milliliter ml, then the unit of density is the gram per ml. Unit of density is the gram per ml. Or if mass of gas is expressed in kilogram and the volume of the gas expressed in meter cube, then in that case unit of this one is the kilogram per meter. Kilogram per meter. It is the unit of the density. And we know that the gaseous has much less density as compared to solid and liquid. Why? Because if you consider the fixed volume or area, then in that area number of gas molecules accommodate जर करायचे असते तर number of gas molecules accommodate कमी होणार. पण ते जर सॉलिडचे मॉलिक्युल्स आपण अरेंज करणार असू तर सॉलिडचे अरेंजमेंट कशी असणार, मॉलिक्युल्सची जास्त असणार आहे. त्यामुळे पर युनिट एरिया ऑक्युपाय होणाऱ्या व्हॉल्यूमची नंबर्स जे असणार आहेत किंवा स्पेस जो असणार आहे तो सॉलिडमध्ये जास्त असणार आहे पण गॅसेसमध्ये कमी असणार आहे. दॅट्स वाय डेन्सिटी ऑफ गॅसेस इज लेस ॲज कम्पेअर्ड टू द लिक्विड्स अँड गॅसेस. Then next property, that is the density. Temperature. Temperature T of gas is nothing but it is the what we call as the property of object that indicates the direction of heat flow when it is in contact with other object. Simply it is the direction of energy flow. Direction of energy flow when it is in contact with any other object. Just if I consider, suppose this one is the object, white block on the upper, suppose it is one object, it is the A object, and then it is placed in contact with some other object, suppose B, and suppose the temperature to consider suppose B is hot as compared with the A, means B चं टेम्परेचर हे A पेक्षा जास्त आहे. जर B चं टेम्परेचर A पेक्षा जास्त असेल तर ह्या केसमध्ये हीटचा फ्लो होणार. That is the direction of energy flow, that is from B to A, that is the heat flows from B to A. हे डायरेक्शन ऑफ जी हीट फ्लो आहे ही प्रॉपर्टी जी आहे ही प्रॉपर्टी म्हणजेच त्या पर्टिक्युलर स्टेटची किंवा सबस्टन्सची काय असणार आपण म्हणणार आपण त्याला टेम्परेचर. त्याचं काय म्हणणार टेम्परेचर. डिग्री ऑफ हॉटनेस ऑर कोल्डनेस, इन शॉर्ट डिग्री ऑफ हॉटनेस ऑर कोल्डनेस जे सांगतो आपण त्याला आपण म्हणतो टेम्परेचर. त्याला आपण काय म्हणतो टेम्परेचर. टेम्परेचर जनरली एक्सप्रेस्ड इन डिग्री सेल्सिअस ऑर इन केल्विन. डिग्री सेल्सिअस ऑर केल्विन ह्या दोन स्केलमध्ये आपण टेम्परेचर एक्सप्रेस करतो कुठल्याही बॉडीची किंवा सिस्टीमची मॅटरची. पण रिलेशन बिटवीन देम डिग्री सेल्सिअस आणि केल्विन जर बघायचं झालं तर टी केल्विनमध्ये जर बघायचं झालं तर टी डिग्री सेल्सिअस प्लस 273.15. ओके, टी केल्विन इज इक्वल टू टी स्मॉल टी डिग्री सेल्सिअस प्लस 273.15. म्हणजे कोणत्याही डिग्री सेल्सिअसमध्ये टेम्परेचर जे असणार आहे त्याचं जर केल्विनमध्ये कन्वर्ट करायचं असेल त्याच्यामध्ये किती ॲड करायचं 273.15 273.15 जर ॲड केला तर येणारा आन्सर जे असणार आहे टेम्परेचरचं हे केल्विनच्या युनिटमध्ये असणार. हे काय असणार आहे केल्विनच्या युनिटमध्ये असणार आहे. सो दिस इज द युनिट ऑफ कन्वर्शन ऑफ केल्विन टू डिग्री सेल्सिअस और डिग्री सेल्सिअस टू केल्विन आपण कन्वर्ट करू शकतो. So it is about temperature. The next one, that is the pressure. Next, pressure. As far as pressure is concerned, pressure is nothing but force. Pressure is nothing but force is pressure is force per unit volume. Force per unit force is equal to pressure is equal to जर बघायचं झालं तर ह्या केसमध्ये प्रेशर तर प्रेशरमध्ये समजा एका कंटेनरमध्ये आपण गॅस फिल केला. ह्या कंटेनरमध्ये गॅस फिल केला. ह्या कंटेनरमध्ये गॅस फिल केल्यानंतर पर युनिट एरियावरती किती फोर्स एक्झर्ट झाला गॅस मॉलिक्युल्सकडून. पर युनिट एरियावरती आतल्या कंटेनरच्या आतल्या बाजूनं किती गॅस मॉलिक्युल्सनं फोर्स एक्झर्ट केला. हे जे फोर्स पर युनिट एरिया एक्झर्ट होणार आहे फोर्स पर युनिट एरिया जो एक्झर्ट होणार त्याला काय म्हणणार आपण प्रेशर ऑफ दॅट पर्टिक्युलर गॅस. अँड ॲक्च्युली मोस्ट इम्पॉर्टंट प्रॉपर्टी दॅट फ्रॉम ऑल डायरेक्शन कोणत्याही डायरेक्शनमध्ये चेक केला त्या कंटेनरच्या आतल्या बाजूला तर सगळ्या डायरेक्शननं जो फोर्स एक्झर्ट होणार आहे त्या गॅस मॉलिक्युलकडून तो काय असणार आहे युनिफॉर्म असणार आहे सेम असणार आहे. दॅट इज वन ऑफ द मोस्ट इम्पॉर्टंट प्रॉपर्टी ऑफ द गॅस. ओके, दॅट एक्झर्ट्स प्रेशर फ्रॉम ऑल द डायरेक्शन इन सेम अमाऊंट ऑर मॅग्नेट्यूड. जर प्रेशर एक्झर्ट करत असेल तर प्रेशर कसं आहे ना मोस्ट एक्सप्रेस्ड वेगवेगळ्या युनिटमध्ये एक्सप्रेस करतात. डायरेक्टली आय विल गिव्ह द कन्वर्शन ऑफ वन युनिट टू अदर युनिट. दॅट इज द 1 atmosphere is equal to 760 centimeter of mercury is equal to 760 millimeter of mercury. mm of Hg is equal to 760 torr is equal to again 101.325 it is a Pascal is equal to 101.325 value Newton per meter square again is equal to 101.325 kilopascal is equal to 101.325 kilo Newton per meter square. So these are the some units they are useful in the conversion of pressure from one unit to other unit. Atmospheric conversion सेंटीमीटर ऑफ मर्क्युरीमध्ये होऊ शकतं, मिलीमीटर ऑफ मर्क्युरीमध्ये होऊ शकतं, टॉरमध्ये होऊ शकतं, पास्कलमध्ये न्यूटन पर मीटर स्क्वेअर किलो पास्कल किंवा किलो न्यूटन पर मीटर स्क्वेअर. ओके, म्हणजे पास्कल किंवा पास्कलचं कन्वर्शन किलो पास्कलला करण्यासाठी काय केलं फक्त मल्टिपल 10⁻⁻⁻. अगेन न्यूटन पर मीटर स्क्वेअरचं किलो न्यूटनमध्ये कन्वर्ट करायचं तर मल्टिपल 10⁻⁻3 मल्टिप्लाय त्याचं कन्वर्शन आपोआप किलो पास्कलमध्ये किंवा किलो न्यूटन पर मीटर स्क्वेअरमध्ये येणार. सो सिम्पली दिस इज द प्रेशर युनिट. द नेक्स्ट वन डिफ्युजन. So diffusion is the one of the most important property that possesses only by gaseous state, not by solid and liquid. Not just somewhat possesses by liquid state, but not by solid state. So diffusion is what? Diffusion is the continuously intermixing of two or more gases. Okay, homogeneous intermixing of two or more gases to each other. Okay, without any force of external agency, without any force of external source. एक्सटर्नल सोर्सच्या मदतीशिवाय जर दोन किंवा दोनपेक्षा गॅसेस एकमेकांमध्ये इंटरमिक्सिंग होमोजिनियसली होत असतील तर ह्या जो फिनॉमिना आहे दॅट इज नथिंग बट डिफ्युजन म्हणतो आपण. म्हणजे उदाहरणार्थ दोन चॉक जर ठेवले आपण इथं तर हे दोन चॉक थोड्या वेळामध्ये हे एकमेकांना इंटरमिक्स होणार का? नो, बिकॉज सॉलिड पार्टिकल्स आर दे हॅव फिक्स्ड पोझिशन. सॉलिड्स ह्या पार्टिकल्स जे असणार त्याला काय असणार फिक्स्ड पोझिशन होणार. पण जर दोन ते लिक्विड स्टेटमध्ये विचार केला तर लिक्विड स्टेटमध्ये एक लिक्विड दुसऱ्या लिक्विडच्या ह्याच्यामध्ये आपण पोअर केलं, दे अंडरगो प्रोसेस ऑफ इंटरमिक्सिंग, बट देर इज सम लिमिटेशन इज देर, बट देर इज सम मीन्स वी हॅव टू पोअर दॅट वॉट वी कॉल एज अ गॅस, इजंट इट? ओके, वी हॅव टू पोअर दॅट पर्टिक्युलर लिक्विड इन टू अदर लिक्विड वन, त्याला पोतावं लागेल. हे एक प्रकारचं इंटरनल एक्सटर्नल एजन्सिंग ऑफ फोर्सच आहे. पण गॅसेसचं तसं नाही. गॅसेसचं जर आपण रूम कन्सिडर केली तर ह्या रूममध्ये ह्या लॅबमध्ये सगळ्या प्रकारचे गॅसेस अवेलेबल आहेत. ऑक्सिजन असणार आहे, कार्बन डायऑक्साईड असणार आहे, नायट्रोजन असणार आहे, बरोबर, सल्फर डायऑक्साईड असणार आहे. मग हे सगळ्या गॅसेसचं युनिफॉर्म डिस्ट्रीब्युशन झालेलं आहे. म्हणजेच काय झालं, त्यांचं एकमेकामध्ये डिफ्युजन झालेलं असतं. एकमेकामध्ये काय नाही, डिफ्युजन आहे. डिफ्युजनमुळेच ह्या गॅस रूममध्ये कुठल्याही कॉर्नरचा सॅम्पल जर कलेक्ट केला तर त्या सॅम्पलमध्ये येणारं प्रत्येक गॅसचं कॉम्पोनंटचं पर्सेंटेज जे असणार ते काय असणार आहे, फिक्स असणार आहे. What it indicates that there is a uniform distribution of all the gases. Means in short we say that there is a homogeneous intermixing of all the gases. Okay, that is possessed only by gaseous state, not by solid and liquid state. Not by solid and liquid state. Remember. Okay. These are some measurable properties of gaseous one. Hope you understand all these things one. And in next lecture we are going to cover the next one from the same topic. Okay. Good day.